10.5 new features for troubleshooting. So yeah, Valerii, hand over to you. Yeah, please go ahead.
Okay. Hi there at this late or early hour. I'm going to speak today about some of the new features in MariaDB 10.5 that may help people like me, support engineers, DBAs, to troubleshoot mostly the performance issues that you may still have with this recent release. So I hope you see my screen really well. A few words about me. I'm in this industry for more than 15 years. I started in MySQL AB and joined support there, the bugs verification team, and then worked at different positions in MySQL, Sun, Oracle, then quit from Oracle to join Percona. So there I had a lot of real life experience with complex troubleshooting problems for numerous customers. Also, since I quit Oracle, I went public in my MySQL related activities. So I created a blog, started to write about MySQL and related stuff on Facebook and abuse this media. I have a Twitter account, and eventually this public activity was notified, and I was awarded as a community contributor of the year last year at Percona Live conference. I do not concentrate only on bugs, surely, in my presentations and talks, but today you will still see a couple of MySQL bugs mentioned and several MariaDB bugs mentioned related to the topic of discussion. A word about my presentations whenever you see them, and you will see slides at the talk page at Percona site, and you see something highlighted. It's a link, just click on it, because my presentations are always like a table of content for further related interesting reading. So please use them properly to get maximum possible help and assistance with the topics that may be outside of the presentation itself. I work for MariaDB Corporation for more than 4 years already, but you should understand that I'm not sent to this conference by the corporation, so just a kind of disclaimers. It's my own ideas, views on the features or problems that I describe. So please do not mix my opinion with the one from the MariaDB Corporation in any case, in this presentation or in all other cases. I am speaking only for myself. This specific session is devoted to a subset of MariaDB 10.5 new features. MariaDB 10.5 with the recent GA release that happened this year, we already had several minor releases. So among the numerous features that were introduced, I decided to concentrate on just 3 main areas, and the most important of them is the performance schema. Finally, after like 5 years of no changes to performance schema implementation in MariaDB, we incorporated most of the MySQL 5.7 performance schema. Moreover, we did it a bit differently in implementation, made some additions. So we have a lot of new instruments, a lot of new tables that should help. So a large part of this talk will be devoted to performance schema. Another interesting feature of MariaDB that is always there is a thread pool. Thread pool allows to get a great performance for a large variety of tasks with high concurrency. It has to be enabled, surely, but until recently, it was not so easy to understand what's going on inside the thread pool when it's, for example, slow or kind of hangs or report some unusual things into the error log. So this was changed in 10.5. We have visibility. Unfortunately, it's not all in one place. In MariaDB, a lot of performance-related information is historically presented in the information schema via related plugins. So that's the case for thread pool as well. But we have 4 new tables that provide a lot of details on the internal workings. It's all based on the real-life use cases that could benefit from such an instrumentation, and then it was added. And there was also a small addition to the analyze statement. Well, I just included for completeness. So let's switch to the performance schema as it's the main topic. This slide presents MariaDB performance schema in some numbers comparing to MySQL 5.7. So right now in 10.5, we have almost as many tables as in MySQL 5.7 in performance schema, 80 comparing to 87. We had much less, just 52, because it was essentially 5.6 performance schema. And we have the same number of tuning knobs for the sizing of instruments as in MySQL 5.7, so 42. Some of the tables that were not incorporated into MariaDB are related to MySQL specific features like group replication that we just do not have. So some instrumentation is still like work in progress, and yes, it's also related to replication, and we will speak about that. So these are main areas. What we have instrumented now, we have memory usage instrumented in great details. We have a new alternative way to review metadata logs. We have instrumentation for prepared statements. We have instrumentation for status variables, statements inside stored procedures, a subset of serialization primitives called SX logs, so just more internal latches are now instrumented of those that are usually important for performance studies. We have additional instrumentation for transactions that makes it more complete, the system of events that we can have timed and understand where the time is spent. Now it starts from transaction that consists of statements that pass through different stages, and we have weights. So we also have user variables instrumentation, replication related tables, work in progress. And the most important change that I would like to highlight from the very beginning for all MariaDB DBAs is that since 10.5, the memory allocation by the performance schema itself is now dynamic. So performance schema can use more memory after startup. It's important change, same as in MySQL 5.7, but it's just really new for MariaDB. So let's move to one or several slides for each of performance schema instrumentation details. First of all, I'm going to present maybe some live examples given the time that I have for this talk, and it will start like that. So yet another important thing to know about MariaDB is that even in 10.5, performance schema is not enabled by default. So you have to enable it explicitly when you start. So given that, most of other things are dynamic. Unfortunately, not all instrumentation in MySQL and MariaDB can be changed after startup. It applies to memory as well. So for example, right now, whatever I do, I will not get into account the InnoDB buffer pool in memory instrumentation because the instrument will be enabled too late. It was already allocated. But otherwise, well, it goes like that. So if we check, for example, the number of setup instruments, no, it will be count star from setup instruments. Just a second, I have to better move this somewhere. Yeah. We will see the numbers that I'm going to share via this slide. So what we have additional new additional instruments, 270 additional instruments. Unfortunately, not all of them are properly documented in details yet in the MariaDB own knowledge base. And when I see such things, I report MariaDB bugs to Jira and try to do my best to document stuff or at least present some details. But basically here they are. Memory instrumentation starts, instruments, their name starts from memory. And we can see a lot of memory instrumentation for performance schema itself. This is how we can find out how much memory is used by the performance schema itself, by the way, for various instrumentation. So with these additional instruments that we have to enable if we want to use them. So here we can see a statement that I already tried. You see that by default only 70 instruments are enabled, and now I enable 200 more. So with this instrumented, we can see, we can collect now the statistics about the memory usage, and it is presented in 5 main additional tables, memory summary. The most important one of them is memory summary global by event name. So for each kind of allocation, we will see how many total allocations of this kind of memory happened, how many times the memory was freed, and all that. We also have this information split into 4 another tables by details. Details like the most interesting one is by thread. So we can see what thread inside MariaDB allocated memory for specific reason or area. As usual with performance schema, I'm not going to present general usage details about the performance schema. I assume it's known and it's not MariaDB specific. When we speak about threads, we have thread ID, and thread ID that performance schema presents is not the thread ID that you can see at SQL level. So if you need to find out which user or from what host or what SQL statement the thread is maybe running right now in the process list, you have to join to threads table in performance schema by thread ID. So that's like an important detail. Also, you can split the memory allocations by the user. Username, no matter which host the user connected from, so who actually uses most of the memory. Or you can split it by host, what remote host uses most of the memory. Or you can split it by user and by host, so-called account. You will see these additional columns comparing to the global event name table that I would like to show you right now. It's big enough, so you can surely do it here. Just a second. Memory summary global. Yes, so we have many columns here. I highlighted just some of them. So we surely have event name, and we've seen these names when we enable the events. We have number of allocation calls count alloc, number of free calls count free. And now you can see that if we have more allocations that freeze, then we have some memory allocated for this specific area. If a number of allocations is growing all the time and we do not see at the same speed the growth of free, it means we probably have a memory leak or we have an increasing load. So that's something to care about. We also have total number of bytes allocated and total number of bytes freed, and the difference in between them is reported in a separate column, current number of bytes used. Again, if current number of bytes used only growing for specific allocations, it's suspicious. It can be a kind of memory leak. So this is why these tables are so useful. So we can run all kinds of queries understanding how this stuff work. But to show it in reality, we need some test load. For test load in frames of these presentations, I am going to use Sysbench, different tests, mostly OLTP update index, but also OLTP read-only. There is nothing special in Sysbench usage, so it just starts. I've put some load, and in the meantime, this load starts, as far as I remember, 4 threads that are working with several Sysbench tables, updating them. I hope in the process we have some memory allocations. So let's check. Okay, I do not see it in the history, so I will just type it. Up somewhere far from the recent. Yes, that's it. So I will just try to see top allocation right now. And here I see the allocation for performance schema itself. That's because in this specific case, I ordered by current number of bytes used. So the size, if I order by count a log, for example, so how many allocations happened, I will see yet another different output from the slide, and I know the reason already, because for one of the tables, for one of the tests later, I've augmented the test with a trigger that is calling a storage procedure. So a lot of allocations happens in frame of storage procedures. So the result I see the presentation is different from my previous test. But that's the important stuff. So here we see that in that specific case that I've presented here, most of the allocations happened in pure Sysbench case on range selects. I probably run actually OLTP point select and not update. And there is nothing to suspect about possible memory leak here, because we have number of allocations equal to number of frees. And current bytes used was 0 for this instrument, for example, and we also have historical high and historical low usage, so you can study from that point of view. It's like a large enough topic to study. I would like to highlight the differences we have with MariaDB in memory instrumentation. The implementation is different, and we believe, our developers believe, it's more efficient in MariaDB because they change the way they find that names that you can see, event names, how they are resolved. So in MariaDB, they are resolved at compile time. So the lookup, the select itself should run faster. Important thing again for all MariaDB DBAs is that performance schema itself may allocate additional memory when it runs, and we can verify that. If you are interested in the details of how different this implementation works, I refer to the task that was a part of the performance schema implementation here. So this important addition, which is quite similar to MySQL 5.7 instrumentation for memory, does not come for free. It's not just great stuff added. There are problems, and problems are mostly like that. I will just show you. Like if I compare to less than, no, it doesn't work that way. Okay, I had some test running, so after this test, if I just, sorry. If I just look for global, I have to move this because I do not see, yeah, where for example, some number of bytes allocated, some number of bytes used less than 0. I have a typo. Some number, current number of bytes used, sorry. Yes, so this is the point. If I add limit 1, for example, and show this stuff, unfortunately, the instrumentation has probably some problems, and this query illustrates the problem that is presented in the bugs I've shown on the slides. So in some cases, we can see the output that does not look logical. By logic, current number of bytes used is always 0 or more. You cannot use negative memory. If you use negative memory, you can suspect that either the instrumentation is incorrect, or you actually freed more memory, like here, count free is 6, more than count of allocations, that you had not allocated. It's even a bigger problem. So unfortunately, with some of performance schema memory instruments, both in MySQL and in MariaDB, we have such cases that are a bit problematic long-term to set up a trust in this thing. So whenever I see this stuff that is MariaDB specific, I report it, and here we have 2 bug reports. As for MySQL, as far as I remember, this bug is stated as finally closed in MySQL 8.0.23. They just released 22 2 days ago. So in next release, we will have maybe this problem solved. And maybe the solution will be merged, or similar solution will be implemented in MariaDB as well. So it does not come without problems. And another problem is surely the lack of details in the knowledge base about the memory instrumentation. But let's move on. So while this is the most interesting part for me, there are other instruments as well added in the process, specifically for metadata logs. There are different ways to study metadata logs. Historically, I preferred GDB, and here is the link for the blog post, or a series of blog posts where I show how to do that. Then MariaDB had so-called metadata log info plugin as well, that presented information in the information schema. But actually, performance schema addition is quite useful. It's just single table, metadata logs. The instrument, single instrument, wait log metadata SQL MDL is not enabled by default. So if we plan to see something, we have to enable it. And I'll do this. So let's find where is my... Yeah, so like just MDL. Okay, we changed some 5. One of them is surely the one I want. Let's just check what I've changed. Okay, so here is the instrument we actually needed. The other one was already set as enabled. I can also set timed if I want to find out how much time is spent on metadata logs, log waits, where here I will put wait to do it correctly. Probably including some other stuff. So yes, we see that everything but memory does not require timed instrumentation as well. Memory allocations are not timed in performance schema. So with these instruments in place, what we have to do is just select from metadata logs, and we will see something. Yes, we will see already one row of result. It's a metadata log that is set while we are reading from the metadata logs table itself. It's natural. So whenever you execute any SQL, you have some metadata log set in the process, even though the lifetime is for the transaction. So here we see how it works. One important detail presented on the slide is that, again, as it's usual in performance schema, whenever you see thread ID, it refers to internal thread ID. And if you would like to find out how it looks like in the process list, you have to join to performance schema threads by thread ID column. Again, I'm not going to present all the details about the metadata logs, all kinds of the metadata logs. It's all similar, but not entirely. So I will concentrate on the differences and problems with metadata logs instrumentation in case of MariaDB 10.5. The most important thing is, and I studied it in the blog post in details, there are different new types of metadata logs in MariaDB related to backup stages and backup logs in general. For these backup logs, that should help to things like extra backup from Percona or Maria backup in case of MariaDB to work properly and get a correct, consistent backup while changes are happening in the process. So for these metadata, for these stages of backup, several additional logs were added, and they were added on top of existing originally MySQL metadata logs. So some of the metadata logs were like reused. And what's also interesting that you may see new types of metadata logs in the output of from the metadata logs table. Those not documented in MySQL because they do not belong to MySQL, and those are not yet documented in MariaDB as well because it's work in progress. So for this, I reported a bug, document possible log types and values, because there is no other source of information that we can refer to. And there is another thing that I've already shown here probably. Yeah, I've just presented. In whatever query you will see it. So there is this column in the output called source. If you try to do the similar query to at least to MySQL 8, that's what I checked, you will see source file name and line number. So you can find out from where in the code specific metadata log was set. I believe in some cases it may be essential, and I don't know why, but I do not see the source column with any other value but empty in MariaDB 10.5. So I reported a bug. You can follow it and see what happens. Maybe it's related to a different implementation of the case resolution that I mentioned. Maybe it's just a separate bug for this instrument as well, but at least in MySQL 8, it's not like that. So there is something to do here. Another category is prepared statements. So what's good about prepared statements, those are used, by the way, by default by Sysbench, is that they're instrumented by default. You do not need to run setup instruments for anything. There is one table added, prepared statements instances, and you can actually see what's there. Do we have anything for prepared statement instances? No, we have nothing there. Why is it so? Because only active running prepared statements are instrumented. So if we want to see something, we need to generate a stream of, and now we have four of them. So we can see like what's there for each of them. That's because prepared statements are now active. So yeah, it's big enough output with mostly zeros, but my main point, yeah, let's see one of them like this. My main point that we now have an insight into the prepared statements, because previously we do not have a way to time the execution to trace prepared statements through performance schema at all, and it was a big deficiency because many end user applications do use prepared statements. So here we can see It's really prepared statements with an argument. We have owner thread ID and statement ID and all the details. And if there is some problem related to prepared statements, we can trace it now. So let's get back here. There are different kinds of prepared statements. Server side, it's prepare and execute. They are also instrumented, and client side, like calls to MySQL statement prepare if we speak about C API, and MySQL statement execute. So we have these corresponding instruments now. We can see where it comes from. So in the more extreme case, more threads, we can see much more instruments, and well, we can capture commits in the process of the test or anything. I capture just update, it depends on timing. So once again, this owner thread ID is something to join to threads from performance schema. Now, another thing, it may look not really important, status variables. Okay, there is show global status, there is show status for the thread, but the task that was really hard to resolve in the past is how to find out the status of a specific running thread for specific end user, for specific application in the process. One can do that by attaching GDB, and I did that, but it's not trivial, and attaching GDB slow things down, so processing stops. So I'm really happy that there is a way to check status variables now for other sessions at runtime. We added this instrumentation along the lines of MySQL 5.7, but with some additions. So if you check show tables like status in performance schema, you will see global status. So it's for global status variables like show global status outputs, session status. That's for specific session. Status by thread, that's status variables for specific thread. Again, you can join. And to be more or less consistent with the other tables for other instruments, we also have this split by user, by host, and by account. So why not? As an example, this is how you use it in practice. Again, from the similar test run in sysbench, that's the example how you have to join with threads. So here I am joined with threads table by thread ID. And for specific thread ID, what I care about is to show status variables not for my own connection. So I am checking that it's not for my current connection, but everything else. And I am also checking for specific status variables like rows read and rows sent. Why not? I can do it for other sessions. I can do it for sysbench sessions at runtime. I think it's great. We can find out number of individual operations specific thread is performing. So we can verify our assumption who made the biggest impact, who does the most of job of specific kind. It's really useful. Another thing, stored procedures. Until 10.5 in MariaDB, you could find out how much time is spent on call for the procedure, for example, call itself, call statement, but not how much time is spent on individual statements inside the procedure. In some cases, it's a problem because, okay, it may be a huge procedure. You know that it takes time and resources, but you cannot split it into details from the very beginning. You have to do it step by step, analyze the code yourself and make assumptions, verify them. So it's great that MariaDB added instrumentation for stored procedures along the lines of MySQL as well. You can check that public workload for a lot of details. That's the best information you can see in public for the topic in any case. To summarize, unlike all the previous versions, we have 4 additional object types in performance schema. Previously, we had only table. Now we have also procedures, triggers, functions, and events from events scheduler. all these new objects are enabled for all non-system databases. So everywhere besides MySQL, performance schema, and information schema databases. So you do not need to do anything special. You can just check the related instruments. Related instruments are named like statement SP for storage procedure. And there is one exception statement scheduler that's for event itself. In case of storage procedure, you can see that instruments are named a bit strange, like statement. Okay, probably it's a statement inside storage procedure set, probably it's some assignment, set trigger field, okay, maybe assignment to new correlation name to the column, but jumps, what are these jumps? Case expression, what are they? We do not see them in the storage procedure language. Thing is, storage procedures in MySQL and in MariaDB are actually compiled into internal code, internal representation that, for example, for procedure like mine, that I wanted to show, maybe. Let's see if it works. Yeah, okay. I will not show it right now. So it's compiled into these internal statements. And in performance schema, we report timing and all the details for these internal statements. In theory, you can get them by show procedure code command in SQL, but show procedure code works only at debug builds. So I had to create a debug builds to really match and add a comment like that. But still, what's important here that you can see statement, it's a normal SQL statement inside procedure, and everything else, like control structures, loops, and everything. You can find out is the time spent on the loop in itself, on setting some variables, or it's spent on real SQL, and then which one. So that's important detail. In addition, that statements are from procedure are visible as any other statements. We have additional new table, event statement summary by program, that can show you how much time is spent on these statements inside your stored program. You can surely describe and see statement summary by program. See it ourselves. No, that's a bad idea. Yeah, so a lot of rows here. I've highlighted some of them. It's like typical. The rows at the end are more or less same as you can see for any SQL statement. What's unique is this part. So how many statements inside storage procedure were executed, how much server had to wait while executing them. That's important. As for the demo, we can actually I think we can see the results right now after the demonstration program actually worked. So if we select from, no, we cannot do it right now. We have to enable some stuff. So I will do it like that. Update, setup, instruments, set enabled in a rough way. Equals yes, timed equals yes. And I also I enable all the instruments. I will also enable all the consumers. Some of them will surely help us. Consumers do not have time. And after that, if I run the test for some time, I can see this from event. Statements. Summary by Just a second. I need a small hint here. So I will show you how slides work in my case. So if we follow the link, okay. By event name, okay, where name like SP, something related to storage procedure, and let's add the limit and let's see the detail. Where event name, sorry. Yeah, so what we have here is that we, it's wrong actually. That must be right. Yeah, so we have some weight for statement inside storage procedure. So that's the instrument we've just enabled. Can we see it? No, we do not see it right now, but at least we have some, we see the impact. So I will not waste more time on that. You can just follow the blog where I put it in a lot of details. So let's move on to another instrument, SX logs, shared exclusive logs. It's a type of internal latches in InnoDB, and some of them are quite important in general, like dictionary operation log or statistics related log. So this instrumentation was missing. Now it was added, and we can see the time spent on these specific areas as well. The instruments, as you can see, are disabled by default. So you have to enable them, and if you enable them, you can get the details like that. It's for a similar test, OLTP index Lua test. I've run it with different concurrencies, like with 4 threads, as I do now, and with more threads. As a result, you get different transactions per second and different latency. The latency grows with the number of threads, and you can see that in that specific case, for example, the growth is mostly related to the latch part. It's not the only weight that will increase, but for example, to index-related SX latch, index 3 RV log. Why that? Because this update test is changing the data, so indexes are changed. And when it's done concurrently, you have to serialize this. So this new instrument may show you why the latency really grows specifically with the number of threads. So it's a great addition. Transactions instrumentation. Transaction instrumentation is again similar to MySQL, so you can refer to MySQL manual, and there is some information in our knowledge base for these specific instruments. There are some problems that I've already reported with transaction instrumentation, but they are quite minor. So what was added? The single transaction instrument was added, disabled by default. If you want to see transactions, you have to enable the related instruments. You also have to enable the related consumers. 3 consumers were added: events, transactions, current history, and history long, similar to statements, stages, and wait. So now you have a full hierarchy. I will not show you this alive, but for the same or for a similar kind of test, you can now easily or differently answer the question that is quite popular among customers. So I have a long waiting transaction, or I have a deadlock. For transactions involved, I can see only current statement in the show engine InnoDB status output. This current statement does not explain the log set. How can I find out what statements were executed previously? So for this, we have event statement history long in the performance schema, if it's enabled. But it was not that easy to split the sequence of statements in specific connection by transactions. Now you can do that. You can see statements in active transactions. So for this, you just have to join 2 tables. And here I have a history, for example, for my own session, where this actually is coming from show tables, variables like GTAD. It's coming from the system itself for this specific thread. Then I executed select, then I executed a couple of updates. And with all the statements from current active transactions, you can surely find out what locks are set and find out why you have lock waits or did lock. It's really great addition, and it's nice to have now transactions as a separate instance besides just statements, because statements are part of transactions. And now we can see it in performance schema. User variables. User variables is quite a simple thing. You can set any user variable anytime you want. And previously, there was no way to see which user variables are set inside other user session. And again, it was a task from practice that we had to find out, because among these variables we may have those related to queries, used in queries and impacting the plan. So the only way to check user variables was to attach the debugger like GDB, and I did that. But it's not trivial even there, because they are stored in a hash by name, so you need to know how hash tables work inside MySQL or MariaDB. It was not non-trivial task even for experienced developer to find them. So now we can just see user variables in any thread. Like for my own connection, I can check it, and that's actually easy. And you can see all the user variables set. In this specific case, I set A to 10, and I can see it for my connection ID. I can use any other connection ID, and again, join into threads table by thread ID. I can relate that with real connection details like those we see in the show process list. So it's great. As for replication instrumentation, I am not going to spend a lot of time on it, and for one specific reason: it's still work in progress. If you want to follow it, follow please this link. It's mdev 16437, the task that is like an umbrella for related activity. What is missing here is one single table, actually, comparing to MySQL. Replication, applier status by worker. So the idea is to trace parallel replication. It's most interesting when you have multiple worker threads, and your main task, and you can see it in numerous blog posts from Percona, for example, main task is to find out if parallel replication works. What are these worker threads are doing? Are they helping? But without this instrument status by worker, it's of minor usefulness. So you can surely check these tables. I have links, you can read the direct match, but without this one, I would say it's not so interesting. If you are interested on how it's supposed to work, I will give you a hint. One of the ways to find out how a new feature works or supposed to work is to check the related tests. So you can see how in 5.7 it's usually used in this blog post, and then you can see the related tests. There are many in the test suite, and see what's in the plans of our developers for the related things. So I had not set up tests for this presentation. I rely on regression test suite, and I had not yet used this in practice because it's incomplete. So we are done with performance schema, but it's still interesting feature to review in frames of this talk is a thread pool. Thread pool is an old feature. Originally, MariaDB implemented that. The main idea is to have less threads at auth level than you have connections. Nothing new. And somehow manage to execute the same amount of work. It helps to scale better. So it's a cool thing. The way it works is that there are several groups, and by default, you have a group for each CPU. You can configure more, but it's normal to have a group for each CPU or core that you have. And this is for each of the group, you may have one or more threads in the pool. They are added when there is load, and then they are removed when there is no load. You may have a dedicated listener thread among these threads in the pool, but in general, the idea of thread pool that you have like a number of workers that can do any kind of work. And this idea was extended actually to the INFORMATION implementation itself. And internally in my MariaDB 10.5, in INFORMATION, we do not have a specific threads for doing something for many tasks, but we have also a pool of threads of a similar kind. So we can allocate more threads for one work, or then deallocate them, or reuse them for other kind of work, flashing pages or not. So it's an interesting idea that we now try to implement everywhere. For specifically thread pool for user connections, the problem was that it's not clear how it works internally. There was a case when it kind of hanged, and only attaching profilers using the techniques I advocate elsewhere of dynamic tracing, we were able to find out why the way it happened. So as a result of that specific study, we had these additional variables allowing to have a dedicated listener per group, and we have this visibility about thread pool in the information schema. So still, I highlight this stuff that internal workings of the thread pool are documented, but these specific tables are not yet documented. So the most important source of information is the source code itself. I have a link to commit with the details, and surely tests, as I already told you. So we can spend some time checking individual tables related to groups. One thing to know that you have to restart MariaDB to use a thread pool. So there is a variable for that, like show %. So here it is. It's thread handling. So here we see one thread per connection. It can be pool of threads, and it's not dynamic, so you have to restart. And here we have some other variables related to side in the thread pool and stuff like that. So what we can see for group, you will see a group per CPU or per core, and for each group you will see in the table how many connections are to this group, how many threads, how many of them are active, how many of them are waiting. If there is more work to do than can be done now, QE will be of non-zero length. Does this group have a listener thread or not? So all these kind of details. It's a test, similar sysbench test, but with high concurrency and thread pool enabled. So we can study more about the QEs. For each group, we can see which connections. These are connection ID in terms of process list. So these are end user connections. Which of them are in each pool, how much time was spent waiting in QE, and that stuff. It's immediately useful. You can find out why your user thread is waiting, for example, longer than you need. There is also some statistics, global statistics per thread pool. Wakes, stalls, slowdown, throttles, QEs, and all that stuff. It's not immediately useful for me, but it's surely immediately useful for the thread pool developers in case of any performance problem report. Finally, there are also waits. It's an interesting statistics. If it's waiting, what time was mostly spent on? For my sysbench test, the time was spent waiting for disk I/O. In some cases on row log, so it's a conflict on updates of the same row in INFORMATION table. And in most cases, most of the conflicts are related to group commit. So we had to form a group to commit several transactions at the same time. So this way I can see that group commit works. You probably noted that this information is similar to those we can usually see in the performance schema. But as I told you, there is no single solution right now in MariaDB. And as performance schema is not enabled, we still have a lot of information added in the information schema. So one day maybe it will be unified. This day had not come. So the last small feature is related to analyze statement. Analyze statement is an interesting MariaDB feature that allows you to execute SQL statement and collect detailed statistics about the execution, not only the execution plan and some projected or assumed number of rows accessed, but real number of rows accessed per table as well, and real time spent on each step. So instead of sending the result of the query, it sends you the extended details about the execution plan. Similar statement explain analyze was implemented in MySQL 8.0.18. So small addition there, we now split time more granularly for the time spent inside doing something in the table. So I've again used regression test suite and redone one of the statements from it. And here is the addition. Now you have time spent from this total time spent for this specific step, for this specific table. How much time was spent for reading the data from the table and for everything else related to this table. Again, it might be useful in some extreme cases. Time to summarize my talk. MariaDB 10.5 added a lot of interesting improvements for those who care about solving performance problems. They are mostly concentrated around the performance schema. Unfortunately, some of these additions are not yet completed. What's most important, they are not completely documented yet in the knowledge base. So we have to rely on similar features properly documented in MySQL, check tests, and even source code, as one of my slides shown. There are still some bugs in performance schema instrumentation, and it means there is a lot of work for users. I still encourage you to use performance schema, and whenever you see the bug, as we see on this slide, just collect the evidence and report it. That's what I did. Thank you very much for your attention, and I'm ready to answer the questions, if any.
Hey, thank you, Valerii, and for the wonderful talk, and it was nice and informative. Okay, so though we are running out of time, we will put you the questions over general chat. Okay, hope you will answer later on.
Okay, I will hang around. It's just a start of working day for me, so I will hang around on Slack for the entire day. Feel free to ask the question there, please.
Sure, sure. Thank you so much.